All right. On Thursday, when I use this charge on the classroom, I actually wanted to highlight a very common, very general use of a question, which is given a formula to understand how changing one variable affects the other. It's a very common type of question that is asked a lot in the exam. Let's say our general formula. Let's have a look at a simpler example of F equals ma formula. Let's assume if mass is m and acceleration is a, the force then will be F. One can ask, all right, what happens to the F is mass is doubled? So mass is doubled. If mass is doubled in this new case, the F prime then will be 2m times a, keeping the acceleration the same. If mass is doubled, then the new force will be 2 times m times a. Since m times a is already equal to F, one can say that it's going to be 2F. So it's 2 times F. So doubling the mass doubles the force, since this new force is the new force, is equal to 2 times the original force. All right. One can then ask that, all right, going back to the original, what if one increases, doubles the mass and quarters the acceleration? But if the mass is doubled but the acceleration becomes only a quarter of the original one, so the mass is double the original, acceleration is quarter of the original, what will be the new force then? Let's say for this new force, let's use the term new force, that is going to be equal to 2 times the original mass, because mass is doubled, times quarter of the original acceleration, which then will be 2/4 times ma, which in other words is equal to 0.5 times mass ma, which then simply 1/5 times F, since ma is equal to force. We already define it as the force. So this new force then will be only half of the original force. So what we did on Thursday was pretty much similar. We said, all right, let's say given the mass, the original mass m, first mass, and the second mass, let's use capital mass. I think in class we use lowercase m, and the radius r. Let's say in this case, in this scenario, the force is just F. All right. What happens if one increases the first mass by 2, so doubles the first mass, keeps everything else the same? What will be the new force? So what will be the relation? What will be the relation between the new force, let's call it F prime if you want, in terms of the original one? So in terms of this first initial force, what is our new force? Then what we did remember was that, all right, so doubling the mass, since our relationship, if you remember, the gravitational attraction force was G, a constant, times first mass times second mass divided by r squared. or if you like, the original was G first mass times second mass divided by R squared. But we can stick to this one. That's our case, because first mass, second mass, and radius squared. Since the relation is such a way that doubling the mass doubles the force, keeping it the same keeps it the same, and keeping the radius the same keeps it the same. So since the effect of increasing the first one, doubling the first one, doubles the force and nothing else for the other two, then we conclude that, alright, so this force then is, the new force is 2 times F. So the new force is indeed 2 times the original force. So that's the relation between them. Alright, let's have a look at another one. Let's say the mass of the first object increased, so triples. The second mass keeps the same, and the distance between them is halved. What will be the new force? Let's say F triple prime, if you like. What will be the new force instead of the original one? That's the question. Now, that's quite confusing, because mass increases, so the force is going to increase, all right? But the distance between them is halved, so the force is going to be increased again. But how much? Because they become closer and bigger. So I know that tripling the mass will make a tripling effect for the force. That will be the same. But for this one, I know the relation is inversed square, so you need to square it and then inverse it, which means squaring the coefficient of R, which is, you see, it is actually 1 over 2R, if you like. Now you have to square it and inverse it. Square and inverse will make, squaring it will make 1 over 4, and inversing it will be 4 over 1, or in other words, 4. So then the effect on the force then will be tripling the mass will triples the force, and halving the radius, the distance between them, the distance between them will actually quadruples the force. So times 4 times 3, the effect will be 12. So 12 times the original force. One last one with a different color. Let's see if I can be able to choose a color from here. I won't. Anyway, so let's use this for this one. All right. So let's say you increase the first mass. Let's say you decrease the first mass. So the first mass is less massive, and increase the first mass by a factor of 4, and increase the distance between them to 3R. Alright, so you changed everything. The question now is, alright, what is this new force? Let's call it F new, you can call it whatever you want, in terms of the first one. Now let's have a look at the effect of each change on the force. Now the effect of halving the first mass will simply be, on the force, will be 1 over 2. And quadrupling the second mass, will be times 4. So 1 over 2. So halving the force, quadrupling the force, in this case, but also the distance is also increased. Now the force is going to be much less, because the distance is now 3 times the original. So that then will be, but careful, the relation for the distance is inverse square, if you remember, inverse square, which means that you have to inverse it, 3 squared 9, and you have to inverse it 1 over 9. So the effect will be 1 over 9. So as you see, This will decrease the force by a factor of half. This will increase the force by a factor of 4, and this will decrease the force by a factor of 1/9. So what is the coefficient then? So what is this knee force in terms of the first one? Then obviously it will be, let's do it in here, 1/2, this is a different color, 1/2, this one, times, if you like, 4 times this one, 1/9, and that simply will be 4/18, and if you like, 2/9. So the effect will simply be 2/9. Right? So as I said, it's a very common method of asking questions from a given relation by changing the variables, what the force or what the result is going to be. A different one, a difficult one for this one would be, all right, what if we give the force and ask what happened, what should be the radius for the force to be this. So let me try to do this one as well. How am I going to clear this page? Refresh. Here we go. Yeah, that's it. Now, what if, oh, did I want to do that? Let's see if I can have, all right. Here we go. Oh, here we go. There's another one. Oops, third one. I don't want that. Good. So I come here and refresh it. Clear the, maybe I can go to the original one and refresh it. There you go. Now, a different one would be, all right, what should be, so that is, remember that was F, M, and R, that's the original, right? The question might be, all right, what should be the radius, keeping the other two same, what should be the radius in terms of the original R, so that the force is three times the original, right? So this new force, you see, the new force is equal to 3 times the original. What should be the radius, this new radius, if you like, this new radius, new, in terms of the first one, so that the new force is equal to 3 times the original force. Then in this case, what you need to do is, oops, oh, here you go. Yeah, what you need to do is you need to remember that. All right, so going back to the original one, 3 times F is indeed equal to, if you remember, 3 times M G over this new R squared. No, sorry. Squared. Right, because this is basically what F is. And that is equal to G M divided by this new R squared. So from here, which is this relation, which is this relation altogether. So from here we can say that 3 over r squared is equal to 1 over r nu squared, right? In other words, r nu squared is equal to, if you do r squared over 3, right? So if you square root both sides, you get r nu is indeed r divided by square root of 3. You see, it's not as easy as the original case. So this new r then has to be 1 over square root of 3 times the original r. See, it's a little bit harder compared to the other case if the force is provided and the radius is asked. Sorry, the distance is asked. I hope this helps.